Okay, let's begin. So first of all, hello everyone. Welcome and thank you so much for joining us today. My name is Rishali and I'll be your host. Before we get started, I just want to go over a couple of notes for today's session. So first off, today's session is being recorded and the recordings will be sent to everyone in a follow-up email after the event is done. Secondly, you can use the chat box to ask questions at any time, as this is an Ask Me Anything format. And lastly, we will also have a dedicated Q&A session at the end where we will allow the person with the question to have an interactive conversation with our experts. So let's introduce the speakers for this session. So I'm joined here by three of our Ceph experts at CLISO. Dan, our CTO and co-chair of the Ceph project. We have Brian, a senior Ceph solutions architect with over a decade and a half years of experience. Josh, one of our expert developers helping us build practical usable tools for Ceph and our CLISO enterprise storage. So over to you, Dan.
Great, thanks Rishali, and thanks everyone for joining. This is the second we've done this twice today now. We did it in the morning North America time, afternoon Europe time, and now we're here in the evening happy hour in Vancouver for me at least. So thanks everyone for joining. Glad to see you here. We'll get started. So the trigger for this webinar / happy hour / chat was it came out of the mailing list, Ceph users mailing list. There were some discussions and questions about how best to balance data in a cluster, how best to use some different tools that have existed for a while in the Ceph community in order to ease our operations. And we thought, why don't we organize a couple of sessions to let people chat with us, ask how these tools work, and learn from each other, share experience. So it's meant to be interactive. We have stuff prepared to fill the time if there are no questions, but feel free to throw questions into the chat, and we'll try to get to those questions through the session. With that, we can get started. So before I will just do a very brief introduction just to set the stage. In Ceph, I think those of us that have used Ceph for a while, there's a kind of a little quirk of Ceph that isn't quite obvious when you're first getting started with it, and that's that it has a lot of smarts to balance data and move the data around so that all of your servers are all using about the same amount of capacity. All the usage is about the same, and there's internal magic inside Ceph to make sure that that's all balanced. And we call it the balancer. So it uses in maybe a decade ago, this kind of thing didn't exist, and just using the very core crush algorithms and things like this that we've heard of, on paper it looks like it's going to output something. It's going to create a pretty uniform, excellent, smooth data distribution, but in reality, in real life, it doesn't always happen. So we had different mechanisms along the way to balance the data. And these days we use this mechanism called Upmap. So there's a lot of tools and techniques out there in the documentation, in the literature, on the mailing lists, all about upmapping. So this session is meant to kind of demystify what that's all about. Of course, maybe someone just why are we even doing this? Well, there's basically three reasons. You want to balance a cluster in order to make sure that you can squeeze out as much usable capacity as possible out of a cluster. If an imbalanced Ceph cluster might leave something like 10 or 20% unusable capacity, just because of the way that it's distributing the data. Secondly, it's the same basic story for performance. So if we manage to achieve a uniform data distribution, then we're going to make sure that we're getting the maximum performance out of all of our hardware without having any hotspots anywhere. And third, we use these tools also to really assist and aid our operations. And we'll see examples of all this today in what we'll go through. So with that, I think I will hand it off to Brian, who's going to show and kind of demonstrate what Upmap is, what this thing all is. Yeah. And like I said, feel free, it's meant to be interactive. So if you have concrete questions, please feel encouraged to type them into the chat, and we'll get to them.
All right. So, for example, I have this cluster here. And let's see if I like take a look at like all the PGs. When you look at a PG with this view, like you got the PG ID, and then if you look over here, you have two groups of numbers. These are the up set and the acting set. So the acting set is kind of like which OSDs are currently being used for this placement group. So 13, 35, 31 in this example. And the upset is like where it's planning on moving to. So like if you've ever seen like a PG like being like remapped, backfilling or whatever, these sets won't match. So like, maybe, well, let's go and just do an upmap really quick. So an upmap is basically like a small correction that you do in the cluster to say, I want to move whatever's on 31 to OSD 30. So to do that, you would run a command like Ceph OSD PG upmap items. And this is what the balancer essentially does. It just takes in, it has some smarts to like, figure out the right way to go about doing this. But you give it the PG ID, and then you say, I want to move the source. So let's say 31 to 30. And we give it a little bit of time, we should see that PG go into an active remapped backfilling state. So there we go. And if we do the set PGLS, we'll see that it's currently on 31. It's moving to 30. There's also ways to do it where you can actually tell it like, oh, I want also 35 to go to 34. So let me double check on this cluster. Because the key thing is it has to obey the failure domains set by Crush. It's like if you try all moving them on the same host, it just won't work. So let's do this example really quick, and then I'll demonstrate that. So let's go to 35. I want to move it to 34. So it's source destination, source destination, source destination, and so on. So you'll see 31 is moving to 30, 35 is moving to 34. And other things to note here is like, the second column is like the number of objects that are in this placement group. And then the fourth column here is the number that are currently remapped. So since we're basically moving 2 OSDs worth of data, it would be like up to 3,600. So if we actually like watch that, like watch. You'll see this number keeps dropping as the backfilling completes.
And one thing I forgot to mention in my introduction, like, so this in the end, thanks, Brian. Like, this is the mechanism. This is like an internal tool, Upmap, that we basically invented this maybe 10 years ago or something as a way to, 8 years ago, but in order to precisely move the data around. Before we had this mechanism in Ceph, we had to play with like the weights of the OSDs or the reweights, those different weights. And we invented a few different ways to try to get the data smooth across all the OSDs, but they all had different disadvantages, but this is a very precise way. So that's Upmap. And then from that, the balancer is how the balancer works, right? Yep. I was going to show, I can show I don't know if that cluster has a configured balancer, but very briefly, some people ask us like, what's the simplest way to configure a balancer? And it's like, if you do one thing, if you want to do one thing, it's just, this is, for example, a good configuration for the Ceph balancer. I mean, this is the output of Ceph config dump, but really this is when you have Ceph balancer on a Ceph cluster, and you can set like when the balancer is moving the data, so a begin time and an end time, and you can similarly set a day, start day, end, or begin day, end day. And then this is these two at the bottom are the key things that are the non-defaults that we strongly recommend. So this upmap max deviation, it really just squeezes the data as close as possible per pool across all the OSDs. And it also, this value here, it acts as a throttle. in order to not move too much data at the same time. So leave room for lots of client I/O to get through, and don't affect the latency. So this is our kind of very simple. Just set this, and you will just have an easy life with balancing. Yeah, I just wanted sorry Brian, I just wanted to jump in with that because I think I forgot to do it here. Yeah.
Yeah, I'll add to that. The misplaced ratio is like, that's 1%. You don't want more than 1% of your cluster being remapped at a time.
Right.
I think the default is like 5%, which is on a large cluster that could be a bunch of data that needs to move around. So that kind of limits what the balancer does at a time.
Yeah. There we go. Cool.
Okay. I'm going to go ahead and share again.
So at the level, yeah, it's about Upmap and the balancer. But then was there something else we want to show about Upmap, or?
Well, I just want to show this one command. To remove an upmap, you could just do Ceph OSD rm pg upmap items and then the PG name. So that cleared off. So it's now active and clean. Also, if you ever want to see the number of what upmaps you have on your cluster that the balancer has created, that's in the Ceph OSD dump output. So you could just do Ceph OSD dump rep upmap. And you can see it's a slightly different format for some reason. Like there's underscores instead of dashes. And then these are basically a list instead of space separated numbers. Yeah, should we go into Upmap-remapped at all?
Sure. So maybe we can talk about some
tricks.
Some what can we do with beyond balancing a cluster? We can do some interesting things after having that mechanism Upmap, being able to exactly move the data where we want. We got some ideas. I mean, a decade ago, we started having ideas about what to do, right?
Yes.
Yeah.
So on this cluster, for example, I set it up so that this OSD 33 has a crush weight of 0. If we were to go ahead and bring that up to the full weight, OSD.33 to full weight, you'll actually see a whole bunch of PGs go into remapped state. So Dan, in his creativeness, ended up creating this tool called Upmap-remapped. And the purpose of this tool is to kind of hey, I've got all these backfilling, and that's going to take 2 days to complete. Why don't we just make the cluster healthy right now, right away? So if we run Upmap-remapped, it basically figures out all the upmaps that it needs to create to say, stay put. Whatever OSDs you're on now, stay there. Don't try to move to new ones. So it basically comes up with a whole list of commands to run. So you could just pipe this into SH, and it'll go through, and you'll start seeing that all of these remapped ones go into an active clean state. Sometimes you'll have to run this twice because if there's already an upmap on a PG, you have to clear it before you create a new one. Because sometimes it's not always clear what the new upmap would be. So we just let that run really quick.
Yeah. So this is you're simulating a scenario where, for example, you've just bought a new host or something. We're doing it for one OSD, but it's like as if you just bought a new host and you need to put it into the cluster, right?
Yep.
Yeah.
Say if you the main reason you want to do this, if you buy an entire rack of servers and you try adding them to the cluster all at the same time, pretty much all of your data is going to new locations, which is going to cause quite a bit of I/O on your cluster that on a busy cluster you may not want, because it could be impacting your clients. So instead, what you want to do is you want to tell that data stay put, and then slowly change those, bring those systems in by just enabling the balancer to actually do the balancing for you.
Yeah, look at that. It's almost at 0%. So it hasn't actually moved. It hasn't actually moved the data, right? It's just moved. It's only Crush wants to move the data and Ceph wants to move the data, but we're using these upmap things to just pin the data back, stick it, lock it in exactly where it is right now.
Yep.
And then behind the scenes, like why do we do that? That sounds like a nonsense, right? So behind the scenes, we know that the actual real balancer, the thing that we were looking at earlier, Ceph balancer on the thing that smooths out the distribution, it's going to look at the size of that disk and it's going to realize, wow, there's like it's supposed to have 7 terabytes of data, but it has 0 bytes of data. So it's going to start manipulating all of those upmap entries that we just created with that tool to move them, right?
Mm-hmm.
Yeah, okay.
And we can see it. If I enable the balancer now, it'll actually start trying to move data onto those drives. And this could also be used for like draining OSDs, but draining them is a little bit different because you can't create an upmap for an OSD if it has a crush rate of 0. So one trick to get around that is if if you want to drain like an entire host, you set the OSDs on that host all to a crush rate of like 0.00002, which is the smallest value that you could legally do.
Yeah. How do we see how many PGs are actually on an OSD?
Okay, you could use the Ceph OSD df command or the Ceph OSD df tree command to kind of show you with each host. So you can see this one that I recently added. It currently only has 18 PGs on it because that's all the balancer has moved onto it so far. But if we were to keep an eye on that, it would keep going up to probably around 130, 140, somewhere around there.
Awesome.
Oh, there's another batch. So if we look, we should be able to see more on there. This one's going quick because it's hitting PGs that are really small first, where later pools have much bigger PGs. So it takes a lot longer to backfill this.
Yeah, each time I think there's a balancer interval as well that runs by default, it runs once a minute and it picks up to 10, I think, PGs that it will upmap. And it also, but first it picks one pool. It looks at one pool, randomly it selects one and it's like, okay, I'm going to balance that pool, and it picks up to 10. There's a lot of configuration in the docs that lets you select which pools to balance and things like that. But out of the box, it's just doing them all randomly. So this thing, I think there's one more. So adding OSDs, draining OSDs, and then there's one more like super awesome use case I just learned about recently.
Yeah. So one of the things we found is like some of our customers, they come to us and they have like pools that are like have a lot of data in them, but they didn't scale their PG counts like appropriately. So these PGs are big, like sometimes like a terabyte, and they take up like 10% of the drive. So it's very difficult to, move those around easily because like it could cause another OSD to become backfill full or too full or something like that. So what you could do is you can actually split the PGs and then use like a map remap to say, I want that to just go back to where it was originally at. So that way you don't have to move any data. So you could do like multiple layers of split. So you could go from like, say 32 PGs to, 256 without having to like go through multiple cycles of, going from 32 PGs to 64, which moves half your data. And then from 64 to 128, which moves half your data. You basically do it as like one big batch, and then you just, enable a balancer, or you just write some script to remove the upmaps to end up moving the data where it was originally going to go.
Right. And Josh, you used that in real life on one customer cluster. And what was how much was the speed up?
So we were splitting PGs from it was like a big cluster, 800 OSDs, and it was 4,000 PGs in the pool. And we wanted to increase it to 8,000. If you probably just like increase the PG number from 4K to 8K, it'll probably take a couple days. But in order for it all to split, because it involves like data balancing. But if you use Upmap-remapped, kind of use that, it'll take like an hour or two, kind of like just a day at the worst case.
Yeah, so like 10x speed up. On that, I think that was an all flash cluster. Like when we do this on spinning disk clusters, those kind of splittings can take weeks or months, even sometimes. I think depends on how busy and how busy and how fragmented everything is. But it ends up being a massive useful tool for that use case.
Yeah, and I actually thought of another use case that we didn't mention this morning, and that's like, say if you have a wall DB drive that's backing, or like you have two wall DB drives and each one's backing like 4 OSDs, and that wall DB drive dies, it takes out 4 OSDs at the same time. And because of the way Crush works, where it uses like the full weight of the server, it tries to put most of those PGs onto the 4 remaining OSDs on that cluster. So you'll get into the state where it's like, they're degraded, but then they become backfill too full. So it doesn't actually like end up backfilling your cluster, which, is kind of unfortunate. But what you could do is you could use Upmaps to like say, hey, go ahead and move those to other OSDs on the cluster. Currently, the current balancer doesn't do that, but we've got something later that we will show that we'll end up doing that for you, which is going to be a nice improvement.
Right. So we got a question from John. What's the biggest PG number that we recommend, PG per OSDs, and then how IO intensive is splitting the PGs?
Okay, I could give my thoughts and you can give yours. I personally like to keep between 100 and 200 PGs per OSD. And that's just so that way, when you move a PG, you want that to be about like 1% of a drive. Like 10% of a drive is really can be time consuming to move. And also it's like, it's a really big chunk to do all at once. And getting your cluster balanced works a lot better there between 0.5% per PG and 1% per PG.
Yeah. The PG numbers are, for most cases, if you're doing block storage or Ceph or S3 and the object sizes are all kind of around 1 megabyte to 4 megabytes or something, then that usual number of around 100 to 200 is usually good. The corner cases are the problem. Sometimes maybe someone has a use case and they're storing hundreds of millions of very tiny objects. Usually that's the problem. If you have like huge numbers of objects in a cluster, then that ends up being huge numbers of objects in a PG, and then you have to start looking more at even increasing the PG number higher, just to have the number of megabytes or gigabytes in a PG won't be so large, but the number of objects within a single PG starts to get very high. So, but those are very extreme, kind of like difficult cases to diagnose. The general rule of thumb, the default right now is 100, but I'm not sure, we might have merged it yesterday or merge it next week, but we're actively working on changing the default to 200 per OSD, so that ends up being the new default. It gives you some better performance. Once you start, like, you don't want to do 1,000 or 10,000 PGs per OSD. That starts consuming too much RAM, and the size of the PG maps and the size of the OSD maps all get way too large. So you don't want to have 1 million PGs in one cluster. There are things that have to be communicated around. So these numbers, 100, 200, 300, they're all quite sensible.
Although, isn't there some issues that we run into that we have to adjust variables? Because when you're moving things around, sometimes they'll spike up to over like 750 and the cluster won't let you do that.
That's right. Yeah. There are some hard limits on the number of PGs per OSD. So in order to, if you do want to change the PG number, there are 3 or 4 config settings that you have to set in order to do that safely. Yeah. And IO intensive, PG splitting itself is not very IO intensive. The issue is that if you just let Ceph do it, if you just increase the PG number, or let the PG autoscaler do it, it has some throttles and internal brakes to slow itself down and do it at a kind of stable rate. Actually, the way that splitting works is it has all the objects on one OSD, say, like, or the piece of the objects on one replica on one OSD. It just like logically cuts that in half, and then it's like the second half now has a new PG ID, and then Crush will compute that here's 3 new OSDs for that one, and it just starts moving that to the 3 new OSDs. So that's our trick. Our trick with Upmap-remapped is, okay, the OSD just like logically split it into 2 PGs. Now we have a new PG on this OSD. Well, let's use Upmap-remapped to just like tell Ceph, like, no, that PG lives right there, exactly where it is. Don't move it. So now you have 2 PGs instead of where it used to be just 1, and they're both half the size of the previous. So the whole thing's not very IO intensive. It's just that PG splitting that involves a lot of backfilling again, and you have to move data. You have to basically move half the data. If you double the PG number, you have to move half the data of the cluster. So that was what Brian was saying earlier. If you go from 32 to 64 to 128 to 256, each time you do that, you're moving 50% of all the data in that pool again and again and again. So we prefer to just go from the beginning all the way to the end using Upmap-remapped the whole time. And then once we're at our PG number that we want, okay, let the balancer move those PGs somewhere if it needs to.
Yeah. And then there's one other thing I want to demonstrate, like with Upmaps, is like you can't move, like you can't break failure domains. Like you can't say like, I want all of these 3 OSDs to all be on Ceph 3, for example. So like, let's see if we even try to do that, what happens. Like, let's say I want to move 13 to 24, 35 to 25, and 31 to 26. This is a developer tool, so they'll still say that it's doing it, but if you look down here, it didn't do anything. So it just basically it logged it as, you know, you can't do that. We're not going to let you create that.
Yeah. Right. So there's a good question from Joel, and then we can show something cool, some cool stuff that we're working on, right? You want to take it, so I can read it, and to add 1,000 OSDs, and then you also having to increase the PG number to account for those new OSDs. What would be the best order? Split the PGs, then add, or the other way around, or something else?
I mean, you could do it either way. If you split them beforehand, you might end up with too high of a PG count per OSD. So maybe what you would want to, well, I don't know. I would probably go ahead and move it, or like, I don't know, what would you do, Dan?
I think, yeah, exactly. I mean, it would probably, they're kind of equivalent, but we probably need to look like, for example, if you had one of these cases, if it was a cluster with zillions of tiny objects, then probably split first, because moving tiny objects takes a long time. If they are, maybe splitting first is always the best idea, but you got to make sure that you don't have too many PGs on on one single OSD. Maybe that's because you're always like, if you split first, then you're always, and if you split first after checking that it's okay to have that many PGs on one single OSD, then you're always just going to move those those smaller PGs, those half-sized. Like say if you double the number of PGs, are you going, Joel? Are you going from 1,000 to 2,000, or are you going from 9,000 to 10,000?
Yeah, if you're going from like 100 to 1,000, that's going to be,
yeah, you won't do, you'll have to move first, and then you'll have to add them first and then split.
Yeah, we're going from about 417 to, and we're adding to that about 1,080.
I would add them and then split after. In that case, I don't know. What do you think, Brian? Because I would add them just means exactly what we just did. Create the OSDs with crush weight 0.0. It's initial crush weight 0.0. Create all those OSDs. They're in the cluster. No data moved. Now you have 1,000. You have a cluster with 1,400 OSDs, and then set the no rebalance flag, which we didn't show, right? Set the no rebalance flag. Set the crush weights to the good value for all those drives, 1,000. You're going to have a lot of peering. It's going to look scary, but no data will move. And then run that Upmap-remapped script twice, and you'll have health okay, and all the PGs will be active clean after that. And then you unset the no rebalance flag, and you'll turn the balancer on, Ceph balancer on, and then behind the scenes, the Ceph manager balancer will gradually, slowly move the data from your 400 OSDs over to the new and fill up those 1,000 OSDs. And then once enough data is on those new OSDs, split them. That's what I would do. Do you think, you agree, Brian?
Yeah, I agree with that.
Yeah.
Also, this no rebalance, you want to set that because, when you're changing the crush weights, it's a lot of peering. You don't want those PGs to also be like backfilling while you're doing all that peering, because they're going to be basically having to they'll backfill and then they'll have to move to a new drive and they'll backfill some more and then move to a new drive, backfill more. So it's best to just don't do any backfilling while you're doing the reweights.
Yeah.
But yeah, definitely start with the Ceph OSD crush, initial crush weight to 0.
Yeah. So seeing the progress of a thing like that's really difficult. So that's one of the reasons why we're starting to work on something new. So you want to show what you're working on, Brian?
Sure. So I actually created this tool called Coral. It's for the ISO optimized rebalancer. It has some features to actually do the balancing, and it's still pretty new, so it doesn't do everything I want yet, but it does actually balance the cluster. It just doesn't take care of some of the situations I think will make it even better. But you get this kind of cool preview mode where it takes into account the the acting set of OSDs and the upset, and it kind of gives you where it's at today and where it's going to be. So right now it's this drive it's using 0% and it's going to be at 0% because there's nothing remapped on the cluster. But say if we go through and we run it with the dash-apply option, it'll go through and balance the cluster. And if at the end of this, it'll actually show that that drive comes completely into the cluster. And we can actually stop this and show it a preview here. We'll just wait for it to finish peering. But you'll see oh, this drive's now going to be 10% full because of all that balancing that we already did. And you see kind of all these ones that are -1 PG. It's pulling a PG from that drive, pulling from that drive. For some reason, it's adding 2 to this drive, but pulling one from there, one from there. But this one's adding 16 PGs. So we would just let it run. The final version will actually be smart and kind of not do all of it at once and just apply it in a smart way. Focus on drives that are almost full first. Move data off of those before you just do other pulling other OSDs up.
Yeah, because that is you mentioned it earlier, but it's worth repeating. I don't think it's commonly known, and I mean, well, I learned it recently. The Ceph and the Ceph balancer, when it's in a state with backfill to full, if anyone's unfortunate enough to have seen that state in a real production cluster, backfill to full or OSDs near full or things like that, the balancer can't get out of that situation. It does not have the algorithm that it uses is not designed to move things from the most full OSD to something else. It's surprising, but actually just moves data if the OSDs, it would eventually over time perhaps, but it doesn't do those first, which actually then can put it into a sort of a deadlocky type situation. It just moves OSDs that are the most distant, most deviant from the average for a pool, and sometimes that's not the most full. Sometimes it's another. Yeah.
It'd be the emptiest ones would get taken care of first instead of the most full.
Exactly, and it doesn't look at things like the backfills that are already in progress and things like that. So it doesn't have any doesn't have any kind of smarts like that. So that's all that we're going to add to the Coral balancer, things like that.
Yep. One of the other features I got planned is I mentioned earlier how if you have WallDB drive and then tries to move a whole bunch of data to the other half of the drives in that node, one solution is to set the crush weight to 0 on the ones that are down, but that causes double data movement when you end up doing that. So you want to keep it that way, but the idea is look at all the degraded PGs and it's targeting 50 towards this one OSD. Spread that as wide as possible across the cluster, so that way your recovery period happens as quick as possible, because you're always limited to the OSD that has the most backfilling to do, or most recovery to do. So if you could reduce that to like, instead of 50 going to that one OSD, you do like 3 to every OSD in the cluster. It'd be a lot faster. So that's one of the plan features that's not implemented yet.
Yeah.
All right. So if you see now, it's like all of these are within like about 1 or 2% of the goal, or of the average.
Yeah.
So there's other features too, like we do PGs. Like this is kind of like the internal calculations, like behind the scenes. It actually breaks it down per pool for each OSD. So OSD 58 is part of all of these pools, and like it wants the number of PGs to either be between 24 or 25. So if it's below that, it'll say like below, and if it's over, it'll say over. But it's trying to target it, and this is just a quick check to see if they're all okay. So this could actually work in your cluster today. So you could pull it down. I don't know if anyone's provided a link to it yet, but you could just do these preview things to just see how your cluster is doing right now. Oh, yeah, Josh just provided the link. Is there anything else we should go over on this one, or?
I mean, yeah, so there's a link and all that. So are you able, Josh, to show how to get access to this and show a demo and where that is, and what we're doing next with this stuff and how people can use it?
Yeah, sure. Yeah, I shared the link to the Coral balancer, but I wanted to just quickly talk about as well. I'll link the Upmap-remapped script here. But we also have a tools container that we've been working on. So let me share my screen for a second. So just a bit of context. I work with support, so kind of doing like Ceph support and all that. And one of the things that we find with our support team is that we have like the Ceph ADM containers and the Rook containers. They don't share packages with the host, and debugging stuff becomes really cumbersome because you got to download all of the tools again inside the container and all that. And for anybody who's using kind of Ceph ADM, they're very like bare bones. It doesn't have like packages for kind of debugging. It doesn't have less any like pager stuff also. So we've kind of created the container that the support team Kaiso use, and we find it pretty useful so far. We've been using it for a couple months, and these are kind of just the upstream containers with extra packages installed. So these are built for kind of each release, and we kind of update it per what we find useful. So one of the things in here is kind of the Upmap-remapped script. We have like some debugging tools in here, like a wall clock profiler for kind of figuring out what when things are slow and all that. And I'll demo it like in a couple seconds from now. But I'll share the repo link there. But all the scripts and kind of like how to build the containers are here as well. So we've kind of pre-built our containers here, and more than welcome to use them. Or you can kind of just like compile the containers yourself and kind of add your own tools to it. But we've kind of given kind of like the cookbook or like the recipe here and like kind of how to do that. Now I'll kind of share my screen with a terminal here. And I just have like a small Ceph ADM cluster here, and I'm just going to copy paste one of the commands in here. So similar, if anyone has used like Ceph ADM and familiar with like Ceph ADM shell before, this is exactly kind of like similar functionality. Puts you into like one of these containers, pre-pulled the image already, so it didn't kind of download. So, and in here you can kind of do all the Ceph status and stuff, but we kind of have the pools pre-populated in here. So in here we have like the auto in here. We have I can just demo, which is kind of like compilation of kind of like CLI tools that we have. We have Upmap-remapped in here. And And these are kind of tools that are currently our support team kind of finds useful. We have like a list of scripts in here as well, kind of debugging and all that. And yeah, so this kind of like would work in probably any cluster. Ceph ADM Rook. You can also do it in packages. I guess the only dependencies you need a kind of container runtime, Docker, Podman, and all that. Yeah.
In a couple of weeks, we're having another. I mean, I think Rishali will mention it again, but we'll have another webinar focusing on CephFS. When is it? CephFS for disaster recovery. Is it next week or is it the week after?
24th June.
Voila. So thank you. So yeah, 24th of June, we're going to have a webinar talking about CephFS recovery and disaster recovery, and this container is going to be we'll be using this one to show our tools that we have for that. So yeah, we really find this thing useful, like Josh said, and encourage you to give it a try, give us feedback, and we want our the goal of all of this stuff is to help make Ceph as easy to run as possible. So if you find these things useful, or if you have other feedback, just let us know. We'll be happy to hear it. Yep.
Okay, maybe now's the time for questions. Yes, everyone, now is a good time. Everyone who has questions, just drop them in the chat box and we are gonna answer those.
Do we get maybe some? It's obviously a very happy hour for everyone. They're extra happy, extra quiet and shy. Do we have thumbs up or thumbs down? Do these tools look useful? Does this information look helpful? Great. Thanks, JC. I think, okay, good. Imagine if someone was saying no. What kind of question am I asking? Yeah.
It's good to see all the stuff you're working on. Really appreciate, and yeah, it's not really early, especially first call was at 6 a.m. this morning, so but yeah, I always enjoy it, and it's just again, it's just great to see all of these alleys that you push into and creativity that you bring around Ceph. So yeah,
Great. Thanks for the feedback, JC. So yeah, there's a lot of, and last or 2 weeks ago, we were at Ceph Day Seattle and we demoed a different set of tools that we're working on. So we're really, if you I guess subscribe to our stuff, and you'll see you can see we've got a lot of different ideas and kind of R&D type things in progress. And this container image and some web services that we're building, we're going to be coordinating and bundling these things all together into something coherent, usable package for everyone. Yeah, that's watch the space.
So we have one question from Joel. Will Coral eventually include an option to automatically deal with the wall plus DB failure case?
Yeah, that's the plan. So I'm thinking of at least a first phase where it takes all the degraded PGs and kind of spreads them across the cluster. Is we'll take care of that case. So the idea is recover quickly and then, balance, even better after that.
Right. Yeah, because you can balance, you can upmap the PGs that are already in backfill wait or something to find another place that they can backfill to right now to make it all go faster. Yeah. Mm-hmm. Like a network scheduler somehow. Yeah. Yeah. Awesome.
Okay. Just to wrap things up, first of all, thank you so much, everyone, for joining in. So definitely, as I already mentioned, today's session was recorded. So we're going to send it in the follow-up email that's going to be heading your way soon. We will also include a short feedback form in the email. So it's just to know like where do you guys prefer finding us, because we usually post on Eventbrite and LinkedIn pages. So what's going to be the best way for us to reach you guys, because we do plan on having more of these sessions in the future. So that would be really helpful. And yeah, more such sessions. And we're also having one more webinar, which is happening on June 24th. So I'm just going to pull out the registration for that. If anyone wants to, you can go ahead and register it here. There we go. There we go. So yes, so it does have a QR code for the webinar, which is happening on June 24th. And if you want to know more about CLISO, or if you're curious about what we do, then there's one more QR code. You can go ahead and scan that and reach out to us. So yeah, thank you so much for spending this time with us today. We really appreciate everyone joining in. And yeah, look out for our next webinar and have a wonderful time, everyone.